here we consider the integral x square to x cube dt by 1 plus t square whole cube, and which is found to be a function of x. It is phi x. Now the question is that how to find its derivative, which is a function of x. So we are trying to find that one. So for that, we suppose that the lower limit, which is a function of x square is given. We suppose that ux is x square and the upper limit x cube as vx. Now phi dash x is, if we also consider that the integrand to be function of t, so it will be 1 on 1 plus t square whole cube. So the formula is composition of the function f of the upper limit, that is v. So f composition v of x into its derivative, so it will be dv dx with respect to x, minus composition of the integrand function f with u dot derivative of u. Now we write this as, using composition of functions, dv dx, its derivative will be 3x square, and here we can write f of u of x, and derivative of u with respect to x, it will be twice x. Now v of x is given, it is x cube 3x square, and f of ux is given x square, so it will be f of x square into twice x. Now f of x cube, just we put x cube in place of t, so 1 plus t square, so x cube whole square, so it will be x to the power 6 whole cube to 3x square minus f of x square. We find that 1 plus x square, so it will be x to the power 4 whole cube twice x. So it is the required derivative of the function phi. Now if we apply this technique to find this limit, so here we see that if x tends to 0, so we'll find this fraction as 0 by 0 form. So here we apply L'Hospital's rule, provided both the limit, this limit and this limit as x tends to 0 exists. So now from first fundamental theorem of integral calculus, if the function ft, here is the integrand, is integrable, then capital F, which is a function of x, will be continuous, and if f is continuous at a particular point c, then capital F will be derivable at that point. So here we say that e to the power root over 1 plus t is a continuous function, so this one will be a function of x, so it will be derivable. So we apply this one. So its derivative will be twice x with respect to x, and this one, so application of this, if we consider this one as phi of x, so its derivative will be, now lower limit is here x square, here lower limit is 0, so what we get, du dx, derivative of the lower limit, because it is 0, so it will be 0, so this portion will be 0. So what we get, that this one dot dv dx, so f composition v of x will get to the power root over 1 plus t square. So x square will replace t. So it will be x square times its derivative. So derivative of upper limit, so it x square, so it will be twice x. Now we cancel 2, and as x tends to 0 we can cancel x2. So it will be limit x tends to 0 e to the power root over 1 plus x square. So we get as x tends to 0 it will be e to the power 1. So this one. This is the required answer.